Have you ever stopped to think about how our digital world actually works? You know, how your online data is kept safe, how your phone's GPS knows exactly where you are, or how we can predict the path of an asteroid? Well, it turns out a huge chunk of the source code for our modern reality was actually written over 200 years ago by one person. And that's exactly who we're diving into today. We're talking about Carl Friedrich Gauss, a man whose mind quietly designed the 21st century.
But before we get into all that, I've got a quick question for you. Take a second and think about it. How would you add up every single number, from 1 all the way to 100? Seriously, pause if you want to give it a shot. It sounds like a lot of boring work, right?
Okay, the answer is 5,050. If you got that, nice work. But the really interesting part is how you got there. Did you actually sit and add them up one by one?
Because, the legend goes, a 7-year-old Carl Friedrich Gauss figured it out in just a few seconds. His teacher, who was just trying to keep the class quiet for a while, was absolutely stunned. See, little Gauss spotted this incredible pattern. If you pair the first and last numbers, 1 plus 100, you get 101. Then you take the next pair, 2 and 99, you also get 101. You keep doing that and you end up with 50 pairs, all of which add up to 101. So what's 50 times 101? 5,050. Simple, brilliant, and a little hint of the incredible mind he was going to become.
That early flash of genius? Yeah, that was just the warm-up. Gauss wasn't just some child prodigy. He was a true revolutionary. He became known as the Prince of Mathematics, and he would completely redefine what the field was even capable of.
And he earned that nickname, the Prince of Mathematicians. The amazing thing is that his work in pure, totally abstract theory ended up becoming the practical foundation for so much of our modern science and technology. Honestly, in a lot of ways, if you want to understand the world we live in today, you've got to understand Gauss.
So let's start where he did, with number theory. It's a field he called the Queen of Mathematics. And it's right here that he laid the groundwork for the digital security you and I use every single day. So in his masterpiece from 1801, Disquisitiones Arithmetica, he formalized this idea called modular arithmetic. Now the core concept is surprisingly simple. Just think of a clock. Right? If it's 10 o'clock and you add 4 hours, it's not 14 o'clock, it's 2 o'clock. The numbers just wrap around after they hit 12. That's it. That's clock math, and it's the heart and soul of modular arithmetic. And this is the perfect example of how a purely theoretical idea becomes our everyday reality. Gauss's abstract clock math is the engine that powers modern RSA encryption. The system, the very thing that protects your bank account, your private emails, your credit card details online, it's a direct descendant of the number theory that Gauss came up with 2 centuries ago. Wild, right?
But Gauss didn't just stop with the world of numbers. His ideas literally helped us map reality itself, from finding patterns in data all the way to understanding the true shape of space.
I guarantee you've seen this shape before, the bell curve. Now, he didn't technically invent it, but Gauss is the one who popularized it and showed the world why it was so incredibly important. He used it to prove that when you're taking scientific measurements, the errors you make aren't just random chaos. Nope, they tend to cluster around the real value in this predictable bell-shaped pattern.
And that one single insight is the bedrock of pretty much all of modern statistics. Today, the Gaussian distribution is absolutely essential for data science, artificial intelligence, finance, quality control in factories, even psychology. It's how we find the signal inside all the noise.
Now, at the very same time, Gauss was secretly challenging an idea that had been accepted as fact for 2,000 years, the idea that space is flat. The whole world was still running on Euclidean geometry, where parallel lines never ever cross. But Gauss, in private, was working out a completely logical, consistent geometry for curved space, a world where parallel lines actually could meet. He was so worried it would cause a huge controversy that he kept most of it to himself.
And here is where the story gets truly profound. Decades later, this radical, secret idea of curved space became a fundamental cornerstone for Albert Einstein's theory of general relativity. The theory that describes gravity and the actual fabric of our universe, it just couldn't exist without the secret groundwork that Gauss laid all those years before. Gauss wasn't just a theorist, though. He wasn't just scribbling in notebooks. He was a master problem solver, and he used his math to make some unbelievably accurate predictions about the real, physical world.
And his practical genius was put to the ultimate test back in 1801. See, astronomers had just discovered a new object, the dwarf planet Ceres.
But they lost it almost immediately as it disappeared behind the sun. With only a few data points to go on, everyone thought that predicting where it would reappear was impossible. The entire astronomical community was stumped. But Gauss wasn't.
He went and invented a whole new way to calculate orbits. It's called the method of least squares, and basically told all the other astronomers, hey, look right here. And when they pointed their telescopes to that exact spot in the sky, boo, there it was. It was almost exactly where he predicted it would be. That moment made him a legend across Europe.
And his practical skills didn't stop with space. In 1833, he teamed up with his colleague Wilhelm Weber, and together they built one of the world's first electromagnetic telegraphs. They sent a message over a distance of 5,000 feet, just another seed he planted that would grow into the hyper-connected world we all live in today.
So how do you even begin to sum up the impact of a mind like this? The truth is, his influence is so massive that it's mostly invisible. It's just baked into the very tools we use to think and to build our world. This really connects to his personal motto, which was pauca sed matura, or few but ripe. He was a total perfectionist. He would refuse to publish anything unless he thought it was absolutely complete and flawless. And what that means is what we have from him is just the tip of the iceberg. His private diaries were filled with incredible discoveries he just never shared with the world.
And yet, even the few things he did publish changed absolutely everything. His work is the silent engine of cryptography, the statistical heart of AI, the geometry behind your GPS, the math that makes space exploration possible, the physics behind telecommunications, and so much more. He really is everywhere.
It just leaves you with this one last fascinating thought. Gauss kept some of his most world-changing ideas, like the geometry of curved space, hidden away in his notes for years. It just makes you wonder, what modern revolutions are hiding in some scientist's or mathematician's notebook right now, just waiting for the rest of us to be ready for them?